In this lesson we're going to look at ways of demagnetizing a magnet, that's to say to remove its magnetism. So we've got a permanent magnet here, and you can see that its domains are more or less lined up in a single direction. So we've got the north pole of the magnet here and the south pole of the magnet here. And before we think about how we can remove this magnetism, let's just remind ourselves what causes these domains. Now, in the first lesson I mentioned that permanent magnets can only be made from materials that possess ferromagnetism. And what happens in ferromagnetism is that each atom of a ferromagnetic material behaves like a little magnet, and the atoms join together in such a way that their magnetic fields are all orientated in the same direction. This is called magnetic coupling. It's not something that you need to worry about at the moment. I'm just giving you that for information, and it is precisely this magnetic coupling which produces these individual magnetic domains in the magnetic material. So if we want to remove the magnetism, to demagnetize the magnet, all we've got to do is heat it. And as we heat it, the individual iron atoms in the material start to vibrate and jiggle around more and more and more and more, and eventually when we reach a certain temperature, what happens is that the magnetic fields stop being aligned in the same direction, and they become randomly aligned like this. Now, the temperature at which this occurs is called the Curie temperature, after Pierre Curie, who first discovered the effect. And so what we can say is that below the Curie temperature, that's Tc, the magnetic fields of the atoms within a domain of the magnet remain orientated in the same direction. Okay, so that's what produces the magnetism. But as soon as we go above the temperature, the magnetic fields of the atoms become completely disorganized, and the magnet will immediately lose its magnetism. So you can see a demonstration of this in the practical demos section under magnetism. Now, each type of ferromagnetic material will have a different Curie temperature. Now, the Curie temperatures for iron and cobalt is actually quite high. It's over 1,000 degrees Celsius. For nickel it's not so high, but for commercial ferrite magnets it's about 720 degrees, and for neodymium it's 600 degrees Celsius. So neodymium is relatively low. In fact, that is the type of magnet that we use in the practical demos section to demonstrate this Curie effect. You can quite easily see that as you heat the magnet, these are very strong magnets indeed, and it's attached to an iron support. And as you heat the magnet, you notice the moment we get above 600 degrees Celsius, the magnet immediately drops from the iron support because its magnetism is all gone. So that's one way of demagnetizing a magnet, is to heat it above its Curie temperature. Another way of demagnetizing a magnet is to position the magnet in a solenoid and then pass an AC current around the solenoid. Now, that alternating current will cause the magnetic field produced by this solenoid to constantly change direction, so you're going from north-south to south-north repeatedly 50 times a second if it's a mains current, and that will cause the magnetic domains in the permanent magnet to become completely disorganized and disorientated. So you'll effectively demagnetize the magnet. Okay, so just to summarize, one way to demagnetize a permanent magnet is to heat the magnet above the Curie temperature for the magnetic material from which it is made. So if the magnet is made from iron, then you need to heat it above 1070 degrees Celsius. If the magnet is neodymium, then you need to heat it above a Curie temperature of 600 degrees Celsius. And the other way is to position the magnet inside a solenoid and then to pass an AC current through the coil. That will cause the magnetic domains in the material to become all jumbled up and disorganized, and so cause it to lose its magnetism.